Hello and welcome. So on the system at the moment I've got the 3D cube demo that I recently showed, and that's a great demonstration of just how much this system has exceeded my initial expectations. Now throughout this build I've used a very simple principle of making individual modules so I can explore the functionality in a standalone fashion and gradually layer in the complexity to build the whole system, whether it be the CPU, the I/O or the VGA circuit. But that approach does have some flaws, because unless you've spec'd out absolutely every detail in advance, you have the possibility that as the design evolves, you discover some of the earlier decisions aren't quite appropriate. So I've hit a little bit of a problem there, so I'd like to show you what that problem is, explain it, and tell you what I'm going to do about it, and hopefully get it all solved today. So I want to talk about the VGA side of things today, where I've got a problem. Now the memory interface has a very low component density because I deliberately left some space just in case I wanted some stretch goal functionality in there, which to be honest, that's not going to happen. I've got the palette, tile map, tile data, sync generation and the output circuit, and that's the kind of functional display system that lets me do the cube demo and a bunch of other graphical things. But the big function missing that I've promised is the sprite hardware. And I've got this kind of L-shaped gap here that is going to be taken out. Obviously I'll have a new backplane by the time this is done with specific headers for the new boards. But this gap here is very small. The circuitry I'm hoping to put there is not going to fit into that gap. So the first thing on my list is I wish to reduce the height of this memory interface board and just give myself a little bit more room for the sprite circuitry, especially this bit that goes over here. But I've got a couple of other things to look at there. The memory interface contains the driver logic for the registers. So there's direct load lines for these scroll-based registers in the tile map. And I did have a thought that some of the sprite registers were going to be locally controlled rather than controlled through here. But actually, if I just add the functionality for those registers to the memory interface, then it's going to be an awful lot easier to fit the additional componentry in there. It's more efficient for space. I've also got a memory map. So I've got the address decoders here define the way that different segments of memory, the palette data, the tile map, and I've already got some reserved lines for sprite raster data, but the addresses of those, the sizes of the regions, I've kind of revisited in my mind a little bit. Specifically, I put aside 4 kilobytes for the sprite data, and I'm going to drop that to 1 kilobyte. I've got a couple of reasons for doing that. When I made the palette, I used a banking register to allow me to address a lot more memory than I've put into the map space, and I can do a similar thing on the sprite data. I want to use the same memory chips for every piece of memory in the VGA circuit, and those are 8 kilobytes, and so I don't want to use just half of it in 4K. But if I bank it into a 1K slot, I can make use of the entire memory chip and give a little bit of general purpose RAM back to the system. So there was nothing wrong with the interface board, and none of these changes are particularly significant in their own right, but they do set a trajectory for the remaining videos in the VGA series that are going to allow us to finish it with a clean looking result. Let's have a look at the PCB design. So whenever I create a PCB outline, I'm putting it here for the VGA, and that gives me an idea of how the final backplane is going to look. And I want to highlight 2 problems I've got here. The output, the palette, tile data, tile map, sync gen and interface PCBs are all designed, and particularly these ones up here took slightly more room than I was expecting, which doesn't leave me very much space for the sprite. I know what I want to achieve with that, and I think it's going to be very tight, and I've got this kind of gap here which is going to be difficult to use. Now I want to separate the sprite hardware into 3 parts, and I'll go into those fairly soon. But I need slightly more vertical room, which leads me onto another problem here. When I did the I/O backplane, it was pretty tough to cross-connect the buses, and connectors in the middle like this made that difficult. So I'm thinking I can solve both these problems if I can make the interface board slightly shorter. If I can get these connectors down beneath here, my life will be much easier. Now it's quite a bit less space, but we were pretty comfortable on that PCB. It's going to give me the space to get over these big connectors. Right, I think that's going to be enough room for the 3 circuits that I want to make. So the next question is, can I fit the interface down into this space? Now, I have made a couple of minor tweaks to this since I actually designed the PCB, but let's look at the big changes. It'll be easier to fix the outline if we go back the other way. And drop this back to a 2-layer board while we design. Okay, I don't think that's going to be an exceptionally difficult bit of routing. Let's go and have a look at the memory map changes though. So the memory map here is controlled by this series of 138 demultiplexers. We're using them as address decoders. So this first one is the most coarse. We pipe in 4 address lines, top bit to an active high enable, and then the next 3 bits are an address select. So each of the 8 lines that come out of here represents 4K out of the top 32K. So we've left these top 2 ones disconnected. That's the 8K we've reserved for the monitor and the stack. Tile map, tile data, they take 2 lines each and we merge them with an AND gate. Then we've got the sprite, which is a whole 4K, and we want to reduce that to 1. Let's get that out of there and daisy chain at that level. So we've got clear 4K in that upper memory section that's now unallocated. Now, daisy chain to here, the next 3 address lines come in to this demultiplexer. So the 8 lines here are each 512 bytes. So for the palette, we merge them together to form a whole kilobyte. This line moves on for more demultiplexing for breaking down the locations of the memory mapped registers. So we moved this entire region up 4K, but then we've moved the memory map registers back a kilobyte. Do the same for the palette. So now we do the same thing we did with the palette and AND them together to create a combined line. And conveniently up here we've got an unused AND gate. One of the little tweaks I made off camera was I added a couple of spare registers in. I'm probably going to use one of these for the sprite hardware. Guess just have to get on and route this. I used 8 for the default trace size before. Of course, I've actually got lots of space in here I can use for labeling, but I could move some of these chips around if I find I'm a bit tight routing. course, the inputs to an AND gate are completely reversible, so we're happy to swap those around if it makes the routing slightly easier. It's actually the palette I needed to switch there. Although we benefit from the sprite line switch over anyway. Might not have been so terrible having these two swapped the other way. People in the comments keep telling me I need to make these ground connections direct and avoid going via the planes. It does make these a little more difficult. This blue trace is kind of in the way. I could try and bring these on the top layer down and under. Let's assume I want to do that. I'm feeling quite good about this layout, but there is some tough bits still to do. Got myself a bit of a tight case here. Now in theory I could swap these address lines around and then reorder all of these, but I'd rather not. Back to the difficult ones. Sometimes the way to solve these problems is just start routing and see where it gets you. Only one data trace left. Fabulous. Turn the power and ground traces back on. Advice I'm being given in the comments is that I should explicitly wire power and ground to the decoupling cap and then go on to everything else on the chip. Separating those is almost irrelevant because the ground fill is going to come in. Maybe this just affects more. Maybe this is more about VCC than ground. No design rule errors. Excellent. Looks good. I also want to make a temporary PCB to bridge this to the old backplane. Looks like everything got very slightly misaligned. Don't like that. Slight enough that it didn't cause us a significant problem at least. Added a couple of ground points there that we put onto the PCB and didn't use. I was worried these address lines were too far from the nearest ground connector to the backplane. we've got 2 PCBs and the stencil. So this is the new memory interface, and then this is the bridging board that allows us to plug it into the existing backplane. This isn't going to be with us for very long, but we need it right now. One of those pins has got a bit less solder on it, but I think it's enough. I could see the stencil was lifting a bit, so these are a little bit smeared out. The solder mask makes this job very forgiving, so I think that's all okay. By far the most common chip here is just these 138s, which are doing the address decoding. They're doing that both for the bulk memory regions for the various RAM chips in the different submodules, but they're also doing it for the individual registers in the VGA circuit as well. It's too high, isn't it? Now that was quite quick, because there's lots of replicated components on this circuit, which makes the pick and place process a lot easier. Let's reflow it. Let's get a look at this. Now, these ones at the bottom here, this is twisted slightly, I think. These ones at the bottom here, it's not obvious if they've connected or not. They're probably fine, but they're suspect. Similar thing here. I'm a little bit worried about this solder. It's maybe dried out slightly. Caps look okay. That solder's at least cleared away nicely. Yeah, lots of joints here look, particularly towards the bottom, look like they are a little bit suspect on the reflow. I think I'm going to touch up a lot of these just because the odds of one of them not being wrong. Most of them are probably fine, but I think it's very likely that there's a problem on one. So on this chip, those top ones look fine. These bottom ones look off. Also on the back is this jumper that controls the memory timing. I could probably have just hardwired that because we know what works from the previous version. That's just exactly the same setting as we put on the old one. Now, crucially here, the outer set of holes should be downward pins that are going to plug into the old sockets on the backplane. Obviously I will do a new backplane that uses the correct layout. And then the inner track are female headers for this to plug into. Apologies that this is going to look very similar to the soldering we just did. Okay, so I've taken the female headers and attached them to the pins. That should allow this to drop on top like that. And now I'm immediately thinking I should have done these female headers before the male headers. Just want to tack these in place for now. Yeah, very awkward trying to get at some of these angles. Be slightly less precarious now. Now for something which is just a temporary interconnect ahead of a backplane refresh, this has taken quite a bit of time actually. Need to get the main build out and give this a test. Okay, that's the old memory interface. The final backplane will of course have the correctly sized thing, but in the meantime we need to use this adapter. Looks like that went in without any bent pins, that's good. Of course I'm expecting this bit to go in a lot easier because we already registered them in. But obviously it looks a little bit funny stood proud, but that's only temporary. The only thing to do now is turn it on and see if it works. Of course we're not expecting the VGA to actually work correctly because all of our code is still pointing at the old addresses. Okay, what I'm seeing here is both good and bad. It wouldn't have surprised me if we saw absolutely nothing. The circuit seems to be stable, but that logo seems to have different issues than I would have expected. Okay, so setting the first palette entry to black seems to have worked in the new location. That's promising. Now, palettes moved, tile map and tile data haven't, but the scrolling registers have changed. Actually updating the monitor to display the correct logo would be quite a bit of work. I've got to write to the ROM and write to the SD card. Let's just try running this demo. Right, that definitely looks like we've got an issue. The palette writes seem to be working. At a guess, the tile data is not responding correctly. Now, I would guess that just means I've got an address bit wrong. And since I didn't change that piece of the circuitry, that's probably in the soldering. There's one at the bottom I didn't like as well. Let's just give this a try, because a couple of bits wrong like that could explain everything we saw. Ah, now that logo is differently offset, but it looks like the right tile data is loaded. Okay, that now looks like tile map and tile data are correct, but the palette doesn't look correct. That's weird. That looked like a problem with the data lines. No, that pin looks like it could be dodgy, but I definitely need to get some fresh solder paste because this stuff just didn't work as nicely as the new tube. Oh, that looks better for the palette. But we still have the tile data issue there. And the logo didn't look right, so I'm not confident we've fixed it. Bingo. Okay, I have to say, I definitely need to pay a lot more attention to how old my solder paste is, because a lot of these joints proved a bit tricky. So I've got a couple of jobs ahead of me between videos. I'm going to need to clean this PCB because I've got quite a bit of flux on there now. I also need to update the copy of the monitor and the ROM chip because the logo drawing on there needs to be updated, as with the copy on the SD card, and of course all the other little utilities and demos where I've stored copies on the SD card. But that would be quite boring, so I will do that off camera. Alright, I take that back. Updating the monitor copy on the ROM wasn't that bad, nor was updating the programs on the SD card. That took me 5 or 6 minutes all told. So now it all works as we'd expect from boot up. So we can see the cube demo is still working, that's excellent. I turned Matt Heffernan's Mandelbrot benchmark into a .com file a while back. I've missed that one on the update because it's not changing the scroll registers. And this is actually a demo I don't think I've shown publicly. So this is just taking the 160 by 120 graphics mode and the line draw function I created for the cube demo and just drawing lots of random color, random position lines. Excellent. Very pleased with that, and I was also very relieved there wasn't any significant problem with the PCB, just a few soldering issues, and I don't need to make a new version of that. Now, we've reorganized the memory, we've created some more real estate on the backplane, and we've added the registers we need for the sprite circuitry, and so that's going to unlock the future progress of this build. And I'm hoping to get started on the sprite circuitry in the very next VGA video. As always, a big thanks to all my patrons and my other supporters. I hope everyone found this interesting. I'll see you again soon. Goodbye.